Okay, I think you should already see the presentation.
Yes.
Okay,
perfect.
Perfect. So, good afternoon to everybody. So, I would like to introduce you the topic on a methodology which may be used for planning energy system and for decarbonize energy system. So, at the beginning, I will give you an introduction of how it is the status quo of renewable in Europe and in Germany. Then the problems which are connected with the integrating renewables, so as well as the solutions. And the last part of the presentation deals with a methodology that we have also used. It is a multi-criteria planning methodology, namely analytic hierarchy process. And I will show you a study case in which, with Professor Styczyński some years ago, we have done for a Siberian system. That methodology can be used also in Europe. I think that about this slide, I have not to comment anymore because we know that in Europe we have some targets. We want to decarbonize the system, and for decarbonizing the system, we need to have to produce electricity from renewable energy sources, and we need also to convert electricity into other energy sources like Professor Dalpet said before, hydrogen. So this is a target, and we want to reach this target in the best way possible. So how is the situation in Europe? You see here that Europe had or has still a target which is called 2020, which means that by 2020, so in some weeks, we had to integrate 20% of renewables into the energy consumption. You see here that at the moment, so if you consider the 2018, in 2018, Europe was had not yet reached the target 2020. Some countries like Sweden or like Croatia or Finland, they have already reached it, or also Italy, they have already reached the target 2020. In other countries like France and Germany, we need to do something more. The situation is also for the integration of renewable or energy into transportation. Also here, Europe set a target of 10% of renewables for transportation. Not all, so just few countries already have reached this target. Of course, we have not forget this. By 2020, because of COVID, maybe the situation is better because also the consumption decreases, and maybe we have reached the target, but it is a not normal situation. Now, looking to Germany. So Germany can be seen as benchmark for Europe. So as you see here, in Germany, we have more than 100 gigawatt of renewables, which is already in operation. Most of these renewables are wind, onshore, offshore. In the last year, the offshore is more and more implemented. The photovoltaic, hydro, and biomass. And the contribution that renewables are giving has increased in the last years. So with more than 100 gigawatt, has been possible to produce about 48% of the total German electricity generation, which is not so small, but the target is to produce 100% in 30 years. So when we talk about renewables, we have also to talk about the cost that the renewables have. Not only the cost of generating electricity, because the cost of generation in the last years decreases because the materials is better, because efficiency of the system is better, but also the cost that the system operator have for integrating the volatility of generation of wind or solar. You see that in Germany, these costs, which were the cost for ancillary services, were high at the beginning of 2010 or 2009, and the last year they decreases. On the same time, the ancillaries or the redispatch activities, they increases. It means that in introducing renewable needs that we need more flexibility on the system. So we need that the volatility of wind and of photovoltaic should be compensated with some kind of flexibility. This is also, you can also see it here in this diagram, how the conventional power plant are scheduled for balancing the volatility of wind or solar, which is this one. And you see sometimes the conventional power plant are asked to produce more power, other times are asked to produce lesser power in order to balance the volatility. So this is the problem. The scientific community is investigating this problem at least since 15 years. What should we do for decarbonizing system? So if you look on the answers that the scientific community gives, you will see that they will address into three main topics. So we need active consumers. We may need active consumers. We need energy storage system. We need multi-energy system. So, in my point of view, we need both of these. So we need to contemplate on the same time active consumers, we need to contemplate energy storage system and multi-energy system. What does the active consumer means? So mostly, if we talk about active consumers, we talk about demand-side management programs, which focus on industrial consumer. Even if small consumers, so the residential one, may be also involved, but most of the load are consumed from industrial consumer. So you see here in these slides different programs that may be developed for making the large consumer active. It means that sometimes it be required that the consumer decrease the peak. Or sometimes, maybe during the off-peak time, so during the night, it may be required that they will increase the consumption, or they will switch the load in the off-peak time, which is load shifting. If they have the possibility to have storage system, not only energy storage system, but also material storage, then they may offer a very flexible load shape. Or if they also are more efficient, they use some more efficient technology, they may also offer the possibility to consume lesser for producing the same amount of product, as well as if they have the possibility that they can modulate the production, they can also increase the consumption, it means the production, and therefore to make some kind which is called strategic growth. So these programs are typical for industrial consumer, which may be applied and may be used for making the industrial consumer active consumer. Besides it, we have also the possibility to integrate into the network energy storage system. Which kind of energy storage system? So most of you knows batteries, but battery, the contribution that the battery are giving now is very limited. At the moment in Europe, we have mostly pump hydro storage system, which were installed 40, 50 years ago on the Alps regions. We cannot imagine in Europe to increase the contribution of pump hydro because the acceptance of population is very low, and also because they are geographically limited. So we don't have a place in which we can think to install or to increase the capacity of pump hydro. Another storage system which may contribute to store high amount of renewable is the compressed air storage system. So in Germany, we have one of the oldest one, compressed air storage system, which is an adiabatic, which means it is an hybrid storage system because it burns natural gas. Anyway, here near Magdeburg, since different years, is in planning or is in consideration to install an adiabatic compressed air storage system, which means that it will not burn any fossil sources. It will store not only the electricity in form of compressed air, but also in form of heat. And storing these two forms of energy, it will be possible to store high amount of renewables. As we said before, in Germany, in Saxony, we have a lot of renewables. Anyway, also in this case, such a solution is geographically limited because they need some caverns in which the storage, the compressed air should be stored, and it's expensive. Now there is not experience in this technology. Batteries are, I would say, in the last years, in the last 3 or 4 years, are used more and more. We have more battery storage system on the network. They are very good if you want to compensate in a short time the volatility of renewables. They are also good if you want to store high amount of energy, but they are very expensive, or they are still expensive. We have to say that in the last years, the cost of storage system has decreased, so they will be cheaper for sure. But at the moment, they are expensive, and some technology like the lithium-based battery, they also are connected with the limited natural resources. So we should also take in consideration that. Another technology, as the Minister Dalbert said, is power to gas. Power to gas, we convert electricity into methane, CH4, and we can convert methane, green methane, into hydrogen. For doing that, we may use also the CO2 coming from industrial system, and we can integrate it, the CO2 together with CH4, which the H2, sorry, hydrogen, and we can feed the natural gas with green methane. It's expensive, of course, the efficiency is low. But there is a very large potential because we can use the infrastructure of natural gas like pipeline, compressor, like caverns for develop power to gas solutions. So the multi-energy system is a combination of all these solutions. So we have power generated by renewables. The power is converted, so may be converted into hydrogen using electrolyzer. The electric power, can be directly fed in the network, used for covering the electric load, using for covering the transportation loads, can be also used for generating heat using heat pump. On the other side, hydrogen can be fed in the gas, can be converted into methane, as I said to you, and then the methane can be fed into a natural gas network. Electricity can be used also for producing heat using heat pumps. So such coordination of many systems is called a multi-energy system, can be a solution for decarbonize the system. So coming back to the methodology. So the methodology that may be used for planning systems should be an holistic methodology, which means we have not only considered an economic criterion, we have not only considered ecological criteria, but we have to consider many criteria. One of the holistic approach is the analytic hierarchy process, which is done, so we have an hierarchical structure. We need to set a goal, and we need to define criterion. We should define also sub-criterion, and we have to identify the solutions. So I will show you at the end an example in order that this methodology is clear to understand, to be understood. So some theoretical information. So as I said, we need to set a goal. We need to make the problem in form of hierarchical structure. We need experts which evaluate, making a pairwise evaluation, the criteria and the sub-criteria. Using the opinion of the expert, we make a matrix which is called judgment matrix. From this matrix, we calculate, I would say, eigenvalue and eigenvector. I will not go deeper. I will show you the example later in order that you can understand. We can check if the expert have done an consistent evaluation of the criteria, and once the check is positive, we can identify the best solution. So, in order to evaluate the criteria, the Professor Sati, which has developed this methodology, has done a matrix like this one, a table like this one, in which you have to point the criteria, you have to give a score from 1 to 9 when you compare two criteria. So supposing that I have ecological criteria and economic criteria, if the ecological criteria compared with the economic criteria receive 9, it means that the ecological criteria is very important, it's extremely important. If it receive 1, it means that it's not important. So once that you have done this matrix according to, so it will be something like this one, you check if the evaluation of the criteria is consistent, and you check using the consistency index and the consistency ratio. It means that if we have an error of 10%, not larger than 10%, then we can say that the expert have evaluated the criteria in a consistent way. Now is theoretically, I will show you an example because it may be easy for you to understand it. This is a study that we have done in Russia, in Siberia. For that, we wanted to plan an isolated power system. I will explain you why. And we have used 3 criteria: economic criteria, ecological criteria, and social criteria. From the economic criteria, we have considered investment cost, how much cost to do that, and how much will cost to produce electricity. From the ecological criteria, we have considered 3 sub-criteria: the amount of CO2 that the technology emits, the amount of NOx, and the particulate matter. On the social criteria, we have evaluated, so we have considered the opportunity that a solution offered in terms of job creation. We have identified 4 configurations of system. The configuration are here. So in the first configuration, we want to supply electricity only using diesel generator. And the second, diesel and photovoltaic. On the third, diesel, photovoltaic and battery. And the fourth, diesel, photovoltaic, battery, and wind energy. So they are the main criteria. We have to choose which is the best one, considering all these criteria that are listed in this diagram. So in order to understand why we have investigated that, we have to see that this is that depicts Russia. The main grid in Russia is the black line here. There are many regions which are not connected with the grid, and they produce electricity using a diesel generator, and many times the diesel comes using helicopter. So we are very remote zones, or use boats. And therefore, in these regions, it may be very interesting to use renewables, since the potential of using renewables also in Siberia is very high. You see They have a lot of wind, there is a lot of sun sometimes, Baikal, for example, and there's a lot of biofuel, as well as the potential of geothermal energy is large. So, yeah, the assumption that we have considered. So, we have considered a diesel generator with such capacity, photovoltaic with diesel capacity, wind turbine, energy storage system, in this case was a battery, as well as inverter. So you see the technical capacity, the economical investment cost, the maintenance cost, the lifetime, and the efficiency and so on. You see that depending on how much the diesel costs, of course, you have different electricity costs. And we have evaluated all the electricity costs that we may have depending on the diesel price. Depending on which configuration you analyze, you have different amount of CO2, NOx, and particulate matter, which have been estimated. And the social aspect have been estimated using the report of IRENA, and maybe you know it, which say that in rural system, for each megawatt of wind turbine or the photovoltaic, 30 or 22 new jobs are created. Okay, so this is a report, so it's reported. Using all this information, the decision maker have evaluated the matrix of judgments in this way. So they have compared if investment cost is more or less important of cost of electricity. If investment cost is more or less important of CO2, investment cost is more or less important of NOx, particular matter or job creation. By making this a pairwise comparison, the decision maker make such a matrix. Since the consistency ratio is less than 10%, which means that evaluating these criteria has been consistent, and we can use such a value. So this matrix can be done also comparing the different configuration of the system that we have evaluated, depending on the criteria: investment, cost of electricity, CO2, NOx or NO2, particular matter, and job creation. So you compare the systems according all the criteria that we have considered, and at the end you have the results. The results say that 48% of configuration number 4, which means diesel, photovoltaic, battery, and wind, is the best one in this situation. It's the most appropriate one. The configuration number 3 has received 20% of value. The configuration number 1, 70%, and then the last one, so just diesel and photovoltaic, is the last which should be chosen. So using such a methodology, you can plan the best solution for that system. And this methodology may be applied also for choosing if it's better to use wind farms or bio or photovoltaic. So it depends also on the configuration, on the problem that you have to consider. So I think I have done. If you have questions, I can answer. Yeah.